you are looking at the most distant thing the human eye has ever seen. It's called the Mother of Miracles because that is exactly what the scientists who found it called it, a cosmic miracle. For 13.5 billion years, its light traveled toward us. It crossed the expanding fabric of space, getting stretched, getting redder, getting ancient, until those photons landed on the mirror of the James Webb Space Telescope. And what they revealed might break our cosmology for good. This is MOM Z14, and its existence raises troubling questions. Light travels at about 186,000 miles per second. That's the fastest anything in the universe can move. And yet, the universe is so unimaginably vast that even at that speed, light takes time, a lot of time. Now, the universe is about 13.8 billion years old. For the first few 100 million years, there were no stars, no galaxies, just a hot, dense soup of hydrogen and helium. Cosmologists call this the cosmic dark ages. Then, slowly, gas clouds collapsed. The first stars ignited. Their ultraviolet radiation blasted through that fog in a process called reionization, and for the first time, the universe became transparent. This moment, the cosmic dawn, is what astronomers are trying to observe. Until recently, the title for the farthest galaxy ever observed belonged to a galaxy called JWST Z14. Also spotted by JWST, it has a redshift of Z equals 14.18, meaning its light was emitted when the universe was only about 290 million years old. That was already mind-bending. Then, a team at MIT's Kavli Institute found something in existing JWST data that looked suspicious. An object appearing in infrared, but dropping out entirely at shorter wavelengths. They pointed JWST directly at it in April 2025, used its NIRSPEC spectrograph to dissect the light into its component wavelengths, and confirmed redshift equals 14.44. They called it MOM Z14, and just like that, it took over the title of being the farthest galaxy ever observed. We were now looking at a galaxy whose light left it just 280 million years after the Big Bang, at a time when the universe was roughly just 2% of its current age. To put that in perspective, if the entire history of the universe were compressed into a single calendar year, the Big Bang is January 1st. This galaxy existed on January 7th. The dinosaurs didn't even show up until December 25th, and we, modern humans, appeared in the last 10 minutes of December 31st. And to think we built a telescope that can actually see it. MOM Z14 is tiny, about 240 light-years across. Our own Milky Way is roughly 100,000 light-years wide, so we're talking about something 400 times smaller. And yet, it is blazing, extraordinarily luminous for its mass and size. Far brighter than our models of early galaxy formation predict it should be. The question is, how? And then there's more. When the team analyzed MOM Z14 spectrum, they found something unexpected: a high ratio of nitrogen relative to carbon. That's unusual, and it's eerily familiar. We see the same ratios in globular clusters. Globular clusters are some of the oldest stellar structures in the known universe. We've always assumed they formed in the first few billion years of cosmic history. But if MOM Z14 already has those chemical signatures at just 280 million years post-Big Bang, then globular cluster formation may have begun almost immediately after the universe became transparent. That rewrites the timeline. So what are we missing about how the early universe worked? What's troubling astronomers is that MOM Z14 is not an anomaly. It's the latest in a growing pattern. Since JWST began science operations in 2022, it has found galaxy after galaxy in the early universe that is too bright, too massive, too chemically evolved for the age we're seeing it at. Our models of how structure forms in the universe, models built over decades of careful observation and simulation, keep getting surprised. It's not that we're completely wrong, it's that something is missing. Maybe it's the role of dark matter in seeding early galaxy formation. Maybe it's something we haven't thought of yet. That's not a failure of science. That's science working exactly as it should. And the more JWST looks, the more the universe defies our models. The record for being the most distant galaxy will fall again. It's not a question of if, it's when. How do these galaxies exist so far back in time? We don't have all the answers yet, but there are theories. A new research has uncovered an intriguing mystery that the majority of galaxies appear to be rotating in the same direction. The lines formed by the peaks here allow us to identify the direction of the curve of the arms of the galaxies and consequently their spin direction. This is significant because in a truly random universe, galaxy rotations should be roughly evenly split between two directions. According to the study's authors, this unexpected finding, which contradicts existing cosmological models, may hint that our universe itself is inside a black hole. To understand this, we need to look at the physics of black holes. When matter collapses under gravity to form a black hole, it creates an event horizon, a boundary beyond which nothing can escape, not even light. Anything that crosses this boundary is forever lost to an outside observer. However, what happens inside the event horizon is still a mystery. This is where black hole cosmology comes in. Also known as Schwarzschild cosmology, it suggests that our observable universe might actually be the interior of a black hole within a larger parent universe. Now consider the Big Bang. The standard model tells us that the universe began as a singularity, a point of infinite density, just like the center of a black hole. If our universe is actually the interior of a black hole that formed in a larger parent universe, it would mean that the Big Bang was not an explosion in empty space, but rather the moment matter collapsed into a black hole, creating a new universe inside. This has another implication. Each and every black hole in our universe could be the doorway to another baby universe. This could also explain why the fundamental constants of nature appear fine-tuned for life. Because black holes that create stable universes may be more likely to persist and reproduce through this process. The scientists believe that this idea could explain several cosmic mysteries. For example, black holes are known to have immense entropy, which corresponds to the vast amount of information contained in our universe. Another factor that could play a role in this scenario is torsion. In extended theories of general relativity, such as Einstein-Cartan relativity, torsion is a property that accounts for the intrinsic spin of particles and can influence space-time curvature. Some theories suggest that this twisting effect of space-time could generate a repulsive force at extremely high densities, potentially preventing singularities from forming. If true, this could mean that instead of collapsing into an infinitely small point, a black hole could experience a big bounce where the core rebounds and expands outward, potentially giving rise to a new universe inside. The scientists continued by adding that rapid recoil after such a big bounce could be what has led to our expanding universe, an event we now refer to as the Big Bang. Instead of a singularity exploding from nothing, it could have been a rebirth from the core of a black hole in a parent universe. This theory would drastically change our understanding of cosmic origins, suggesting that the cycle of universes is an ongoing, self-replicating process. Another intriguing possibility is that the universe may have a preferred axis. Studies of large-scale cosmic structures suggest a certain alignment in the way galaxies are distributed and move, rather than being entirely random. This so-called cosmic anisotropy challenges the widely accepted cosmological principle, which assumes the universe is isotropic and homogeneous on large scales. If the universe does have a preferred direction, it could point to unknown physics at play, possibly related to the way our universe formed inside a black hole or how fundamental forces interact on the grandest scales. Moreover, the existence of ancient, massive galaxies so soon after the Big Bang challenges our understanding of cosmic evolution. But while the universe inside a black hole theory is tantalizing, there could also be a more pedestrian explanation for the unexpected observations. Maybe some earlier measurements of our universe are incorrect, especially the speed at which the Milky Way galaxy rotates. In any case, the universe is turning out to be far stranger than we ever imagined, and the uneven galactic rotations will likely prompt astrophysicists to reassess certain aspects of our understanding of the universe. What do you guys think? Let me know by dropping in your comments below. And as always, don't forget to subscribe to Territory, because this is your space.